Alrighty, children. So this is going to be our day 9 video of Unit 1. And in it, we're going to talk about our first rigid transformation. And this is easily the simplest rigid transformation, namely translations. Okay, so here's our EQs. We can go ahead and answer EQ1. We talked about this in the previous lesson. So you've got rigid and non-rigid transformations. Right? So a rigid transformation is when the figure or function only changes in where it exists in space. Okay, so the size of the figure remains the same. It only occupies a different area of space. It doesn't occupy a larger or a smaller area. It occupies the exact same amount of space, but it basically just moved somewhere else. Okay, so that brings us to EQ2, which I forgot to write literally EQ2 up here, but this is EQ2. So what is a translation? So a translation, so let's use our little basic triangle again, and we're going to call it, so instead of saying A, B, C, we're going to say this is A1, B1, C1, right? And we say that it exists at 0 by 1, so that's vertex A. Vertex B is -1 by -1, and vertex C is 1 by -1. Okay, so a translation is simply when you move it. It's oriented the same way. Obviously, it's a rigid transformation, so the figure's size doesn't change, right? But it just exists somewhere else, right? So let's say this is where I translated it to, where I moved it to. Well, in 2D space, how could I explain how I did this? Well, let's look at the coordinate pairs, right? So A1 to A2. So I've got 5 by 4, right? B2 became 4 by 2. Okay? C2 became 6 by 2. Right? So what happened? Well, let's look at A2 first. So my x coordinate changed from 0 to 5. So I literally did from here to here, I did x plus 5, right? Well, what else changed? Well, my y coordinate went from 1 to 4, right? So I could also say that I did my y plus 3, right? In other words, I went 5 right and 3 up. Okay, and we talked about this in the do now when we were talking about, how would you move something right or left? Well, you would have to add to the x coordinate for it to go to the right. You would subtract for it to go to the left. For it to go up, you would add to the y coordinate. For it to go down, you would add to the, you would subtract from the y coordinate. Okay, so, and if we look, the same thing happened on the other two, right? So B2, right? Well, -1 plus 5 equals 4. And holy dog crap, what was my x coordinate here? 4, right? -1, so we're doing y plus 3. -1 plus 3, well, that equals +2. And again, holy dog crap, right? So we see translations are pretty simple, right? So what if I wanted to move, differently, right? So let's say from here, from A2, B2, C2, let's say from here, I moved over here, right? A2, we'll call this A3, sorry, B3, and C3. Okay, so what happened this time? Well, let's look at our actual numbers, right? So A3 became negative 7 by 5. C3 became negative 6 by 3. Right? And then B3 became negative 8 by 3. Okay, so what happened this time? Well, let's look at A again. So from A3 to A2, how did I change exactly? Well, I went from 5 to negative 7. So I did, from here to here, I did x minus 12. That made me move 12 left, right? And what about y? Well, I went from 4 over here to 5. Okay, so I had y plus 1, meaning I went up 1. Okay, now let's get a little crazy here. Not too crazy, just a little bit. So let's say I did this again, except now that would be up here. Okay, so what on earth did I do here? Well, we can plainly see, so if I call this A4, B4, and C4, we can plainly see that we got larger. The question is, how much larger, right? Well, let's just see. Let's see what the numbers are. So A4 became, what is that? Negative 8 by 0. Okay, and B4 became negative 10 by negative 4. Whole bunch of negatives. And then C4 became negative 6 by negative 4. Okay, so what could possibly have happened, right? Well, obviously I was dilated. The question is, how was I dilated? Well, if you just look at this side right here, now these 2 points, these 2 vertices, B4 and C4, they're 4 apart now. So that tells me that I must have dilated by a scalar of 2, because originally, right, going all the way back to A1, B1, C1, this side right here was only 2 across. Okay, so obviously I dilated by 4, right? So what is the exact order in which this must have happened, right? So if I dilate by 2, this purple one, if I dilate by 2, well, this would be negative 14, this would be positive 10, this would be negative 12, this would be positive 6, and this would be negative 16 and also positive 6. Okay, so we see what our coordinates would be if we dilated, right? So we dilated by 2, and then what did we do? Well, then we had to have translated, right? So I went from negative 14 to negative 8. So this, negative 14 to negative 8, that is x, hold on one second. So negative 14 and negative 8, that would have to have been x, and this seems counterintuitive, but I would have to have added 6 and moved to the right. Because when I dilate this figure, right, it would have ended up out further left, just because negative 7 times 2 put me at negative 14, which would be way over here. So this would be negative 14 by positive 10, which I can't even fit on here. Okay? And how did I go from positive 10 now to 0? Well, I would have to have done y minus 10. Okay, so if I was going to list out how did I get from, A4, how did I get from A3, B3, C3 to A4, B4, C4, right? Well, first I dilated by a scalar of 2. Okay, so that was step number 1. Well, then I would have to have translated. 6 to the right after I dilated, and then I would have to have translated, what is that, 10 down. Okay, so 6 to the right, 10 down. Right, so that's how we can start piecing these together. Okay, so let's make sure I answered all my EQs. I did more or less. So a translation is when we simply move the figure, right? So we move the figure or function up, down, left, or right. Okay, remember, the size doesn't change. None of that happens. It's a rigid transformation, so it stays the same. Rigid means stiff, unchanging. Okay? How do I translate a figure upwards or downwards? Well, you add or subtract to your y value, right? Add is up, subtract is down. Okay, how do I translate a figure right or left? Well, if you didn't catch that from what we were doing earlier or on the do now, so we add or subtract to the x value, right? And adding takes us to the right, and subtracting takes us to the left. Okay, so pretty straightforward with translations. It and dilation are the two simplest to understand. And in our applied practice, as you can plainly see right over here, in our applied practice, we're going to be combining all of these, right? Let me just enlarge this. You don't really need to see any of the text. All right, so in our applied practice, I mean, we're basically going to follow this and be like little detectives and figure out, what had to have happened to go from the red square, which is our first square, A1, B1, C1, D1, to our blue square, right? And we can plainly see that's a translation. The question is, translated how, right? So if you have any questions for me, if there's anything from this video that you didn't understand, obviously come and let me know or shoot me an email. Otherwise, I'm going to close this out. Goodbye.